Hello, my friends. This is Clover, and today we're solving Murdrum by Philip Newman. This was originally posted in GAS on April 9th, 2024. The title, as usual with Philip, is a little cheeky, so it is both a nod to the word redrum, which is murder backwards from the film The Shining, and also to the fact that this is both a palindrome, so you can see Murdrum is spelled the same forward and backwards, and also a killer Sudoku. So those are our rules. We got normal Sudoku rules. We're placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. Then we also have killer cages. So we have some cages in the grid. Digits can't repeat in cages. Not really relevant here because they're all contained within a single row or column. And they each have a clue in the top left corner, and that tells you the sum of all of the numbers that are in that cage. Palindromes, finally, these gray lines, the digits along them have to read the same forward and backwards. It's worth noting that if you have a length 2 palindrome, that basically just tells you that the two digits along that palindrome line are equal to each other. So let's get solving. So a 6 cage, that's got to be 1, 2, 3 if all those digits see each other. 7 cage has to be 1, 2, 4. And then if we look at the palindrome line, these two cells have to have the same exact digits as these two cells. So these can't be 3, so there's my 3. These can't be 4, so there's my 4. Now that I have this 8 cage seeing a 4, I know which of the two possibilities to sum to 8 it is. It can't be 1, 3, and 4, therefore it must be 1, 2, and 5. I know I have to have a 3 in one of these cells because this cage has a 3 in it, and I can't put a 3 anywhere else in the region but here. So this 9 cage definitely does not have either a 3 or a 5. So how do we make 9? We could do 1, 2, and 6, and that's fine. 1, 3, and 5, not going to work. 2, 3, and 4, also not going to work. So this has got to be 1, 2, 6. Now let's consider the 10 cage real quick. So the absolute smallest we could possibly make this pair of two digits would be 4 here and 5 here. And then even if we were to put the smallest possible digit here, which would be a 1, we would only just make it low enough to be 10. So we must have a minimal cage actually here. So now that's a 1, 2, and 1, and a 2 and a 1. That's going to resolve this palindrome line because this can no longer be 1 or 2, therefore it is 6. Now let's move down here. So here to make 23 and 3 that all see each other, we have 6, 8, and 9. These are going to be 7, 8, and 9, and these two cells have to equal these ones, so these are not 7. And these are not 6, so there is my 6. Now 20, the maximum I can possibly put in these two cells would be 5 and 6, right? And that gives me 11. And so I would have to also make this cell maximal to even get to the point of 20. 11 plus 9 is 20. So this has to all be maximal in order to reach 20. Now I know the order of my 8 and 9. Actually, while I'm thinking about that, I'm going to go up here and settle the order of my 1 and 2 using the palindrome as well. Now, we need to make 22 here. We can't use a 6, so we can't go 6 plus 7 plus 9. The only other way we can make 22 in this cage is 5, 8, and 9, which goes like that. Now, this 21 cage does not have a 5 or a 6 in it. There are 3 ways to make 21. The one that uses the smallest possible digit starts with a 4, so it would be 4 plus 8 plus 9. Then we could go 5, 7, 9, which doesn't work in this row. Or we could say 6, 7, 8, which also doesn't work in this row because of the 6. So this is 4, 8, 9. This cell is the same as this one, but we have an 8 and a 9 in the row, so those are both going to be 4s. Now let's take a look at some classic Sudoku. So we know there needs to be a 7 in one of these cells. These guys are going to be 1, 2, 3, 4 in some order. We can't quite work that out yet. Let's actually look at some of these columns here. I think that's going to be a little more fruitful for us. So what do we need here? We need a 3, a 6, a 7, 8, and 9. So these are 3, 6, 7 in some combination. And still, that's not quite looking like it's going to give me much. So what is going to be more useful here? I swear I did just test this one, and I have completely forgotten the solve path. Okay, there we go. So now we're going to look at these two 2s, and we're going to place a hidden 2 in region 8. There's a 2, perfect. And we're going to look at these two 8s, and that places a hidden 8 up here. There has to be a 9 in one of these cells. In fact, what do we have left here? So we need to place 3, 6, 7, and 9. This can't be 3, 6, or 9, so it's 7. And so those are my 3, 6, and 9. That's got to be a 3. And then that's either a 6 or a 9. And then my last digit in this vertical column is a 4. Let's do the same thing down here now. So in this region, I still need to place 1, 3, 4, and 7. That's not a 7. That's not a 1. Those are not 4s. And here I have a 4 in the column, so that's now a 3, a 7, and the entire thing is resolved. Oh, and this 6 also gives me the orientation of the 6-9 pair. So now this will be a 6 to finish the column. Now I need to place a 3, a 5, and a 7. So now I have a little more info that will let me clean these pencil marks. So that's got to be a 6, and then I still need a 3, 7, 8, and 9 to finish the column. This can't be 8 or 9. This can't be 9. So the only position for 9 in column 3 is right there. Now the only position for 8 in column 3 is right there. Now in row 9, I'm going to place a 1 and a 5, and I know which way around they go, because there's a 1 already up there at the top of column 2. These are going to be 2, 3, and 7. That's not a 3. I can eliminate 2 and 3 from these cells, and I can eliminate 1 from right here. Okay, now these are going to be 4, 5, and 9. I can resolve that because there's a 5 and 9 here, so that's my 4. There's a 9 here, so that's my 5, and then I place the 9. These will be 3, 7, and 8. That's not a 7. That's not an 8. These are 1, 2, 3, and 7. None of these can be 1 because there's 1s in these 2 rows already. That can't be a 2 either. So there's my 1, there's my 2. The 2 gives me a 3 and a 2 right there. The 3 eliminates the 3 from that cell. What do I need to finish this row now? I need a 6 and a 9. I don't know which way around they go yet. And here I need a 7 and an 8. I do know which way those go because there's an 8 right here. And now I think I need to start working on the middle of the grid. So I have 2 8s here and here. So I have a hidden 8 in this region. The only place 8 can go in region 6 is right there. That makes this a 3, a 7, an 8, a 3. That's not a 3. These will have to be 5, 7, and 9. There we go. And now I need a 3 and a 2 in this column. This one cannot be the 2, so that's my 3. 2, 7, 3, 7. And I need to place a 2 in this region. It goes right there. And let's finish off this region. So this is going to contain 4 and 7 in that order to finish off that row. And then to finish the rest of the region, I still need to place a 1 and a 5. That was not my actual time. I actually kind of pre-solved that one kind of 1.5 times before starting. That was a lovely puzzle. I am really enjoying this series of kind of cages plus GSP symmetry puzzles from Philip. Hopefully he's got more up his sleeve, and I hope you enjoyed this puzzle as well. So I will catch you next time. Have a great rest of your day.